This is Captain Chaudhari in my series of videos on marine astronomical navigation. I was doing planets, and in my last video I talked about the movement of Venus. We found out synodic and sidereal periods in respect of Venus. Now we are going to study a superior planet. Like, as you know, Jupiter is a superior planet for us, and we will try to do a numerical which shows the movement of the superior planet Jupiter. And as you know, in case of Jupiter we have one conjunction and one opposition, unlike inferior planets where there were inferior and superior conjunction. Now here is a question. It says that you assume that the orbits of Jupiter and Earth, for the calculation purpose, you assume that the orbits are circular and concentric, right? And what it says that Jupiter distance from Sun is 5.2 times the Earth-Sun distance. Also it says that Jupiter was found at 80 degrees westerly elongation, right? 80-degree westerly elongation can be understood in the diagram as follows. Like, suppose this is the Sun, and let's say this is the orbit of Earth, and then suppose this is the orbit of Jupiter. Okay, now if the Earth is here, elongation, as you know, is the angle measured at the center of the Earth in the plane of ecliptic between the directions of Sun and the body, which may be planet or moon. Say Jupiter was found here because the elongation is 80 degrees, right? So this is the diagram we will draw. Okay, assuming that everything is in the same plane. Now if we join this line, we find a triangle, and for the timing we'll assume this to be a plane triangle because everything is assumed to be in the plane of ecliptic. Now this is 80 degrees and we don't know anything much about the triangle except that this is suppose if this distance is x, then distance from the Sun to Jupiter is 5.2x. Immediately what comes to your mind? What comes to my mind is we can relate the sides and angle, like in case of plane triangle, we can say sine of this angle divided by this side is equal to sine of this angle divided by this side. So suppose this angle is theta, then can we say sine theta upon x is equal to sine 80 divided by 5.2x. X gets cancelled, so we have sine theta is equal to sine 80 divided by 5.2. So let's say sine 80 degrees divided by 5.2 equals inverse sine, gives me 10.9 degrees. So I get theta is equal to 10.9 degrees. But we said that this is a plane triangle in the space, in the plane of ecliptic, and we know that sum of all the three angles is 180 degrees. I know this as 80 degrees. Theta is 10.9 degrees. So the last angle will be 180 minus 90.9. That gives me 89.1 degrees. So this angle is 89.1 degrees. Now, from the Sun's perspective, Sun is looking at the Earth in this direction, Sun is looking at the Jupiter in this direction. Let us assume that the Sun is the center of this circular track, and it is like E and J are the two vehicles which are going in anti-clockwise direction. So their direction of movement is same. Both are moving in anti-clockwise direction. But Earth being a faster planet, right? Earth will complete the orbit faster than Jupiter. Jupiter is very far off, so Jupiter's completion of orbit will take more time. That means Earth is always in the process of overtaking. Now what is the rate of movement of Earth can be found out. Earth moves 360 degrees in 365.25 365.25 days. And what is the interval of Jupiter? What is the sidereal period of Jupiter can be found out actually by doing T square Tj square upon dj cube is equal to Te square upon de cube. So basically we can say that Tj, that is the sidereal period of Jupiter, is equal to Te multiplied by dj upon de to the power 3 by 2. Now if we assume that the sidereal period of the Earth is 1 year, then we will get the answer in terms of year. In place of dj I can write 5.2x. In case of de I can put 1x, and this is to the power 1.5. So the answer is x gets cancelled, 5.2 to the power 1.5. So many years. So 5.2 to the power 1.5 gives me 11.86 years. That is the sidereal period of Jupiter. So what is the rate at which Jupiter is moving? Jupiter completes 360 degrees in 11.86 years. So where the Earth's rate is 360 degrees per year, right? Or in 365.25 days, the rate is 360 divided by 365.25 degrees per day. In case of Jupiter, it will be 360 degrees divided by 365.25 multiplied by 11.86. Okay, so let's find out what is the rate of Earth. 360 divided by 365.25 gives me 0.9856. So the rate of the Earth is 0.98563 degrees per day, right? And in case of Jupiter, let's find the rate. 360 divided by 365.25 into 11.86. It's 0.08310 degrees per day. So naturally you can see that the rate of change of degrees by the Earth is much more than rate of change of degrees by Jupiter. So angular movement of Earth is faster than Jupiter. What is the difference? The difference of the rate is 0.90252 degrees per day. But can I say in this circular track, whereby Earth is a vehicle and Jupiter is a vehicle, I have found out the angular rate of Earth, angular rate of Jupiter. I find Earth faster than Jupiter, and Earth is definitely going to overtake the Jupiter, and the angle to overtake is 89.1. How many days it is going to take to overtake 89.1 degrees? So I will have to write 89.1 divided by 0.90252. Let's see how many days. 89.1 divided by 0.90252. So this gives me 98.7 days. 98.7 days. So what happens after 98.7 days? In 98.7 days, if you calculate, you will find that the Earth moves in her orbit by about 97.3 degrees. That means Earth would move to a position something like this. And we say that at that moment the Earth is overtaking the Jupiter. That means the Jupiter surely would reach this position. Right? So this is a situation where the Jupiter is on the opposite side of Sun. So this is called opposition because the elongation of the Jupiter is 180 degrees. So elongation is 180 degrees, and we say that Jupiter will be in opposition. Jupiter will be in opposition after 98.7 days after this observation. We can also find out what is the synodic period of Jupiter by the similar formula. So 1 upon Sy is equal to 1 upon 365.25 difference 1 upon 365.25 into 11.86. Right? So let's do this. So let's find out the synodic period. 1 divided by 365.25 equals minus 398.88. So 398.88 days. So the synodic period is 398.88 days. As you know, the Earth takes 365.25 days to complete one revolution. It means that after completion of one, like here you have the opposition taking place, like the Sun and Jupiter are opposite to each other. Elongation is 180 degrees. So what would happen is the Earth would complete one revolution and reach here, and thereafter Earth has to just move by about 33 degrees, and once again you will find the Earth here and Jupiter here. So while there was one opposition here with Jupiter, there will be another opposition after 398 days where the Earth is over here and Jupiter is over here. So this is what is the synodic period of Jupiter. Now as far as the sidereal period of Jupiter is concerned, I would say that Jupiter, whenever you start counting, Jupiter has started moving eastward around the Sun, and after 11.86 years Jupiter will reach in the same position in space, so that the Sun and any particular star will be in the same line. So that is how Jupiter completes a sidereal period of 11.86 years.